Okay, for the next problem, problem number 9, we're going to work with an integration problem and a u substitution that's a little bit trickier than the ones that we've been doing. So this is number 9, and the problem is the integration of x times 3 to the x squared plus 1 then dx, of course. Okay, so the first step is we have to find our u value, our u substitution. And so we look for our g of x, and we see that right here. This is 3 to the something, and that something is x squared plus 1. So our u value is going to be, I'm going to section this off a little bit. So our u value equals x squared plus 1. And now our next step is to find the derivative of that u function, of that u value, du dx. And so that's going to be 2x. And now when we want to isolate, because we want to isolate du, that is going to equal 2x times dx. Alright, this is when we get into the business. Oh, I just crossed it off a little bit, sorry. So for the next step, we're going to write out this integration. We're gonna look at it like this. So we have 2x dx, and that's our du value. And so in order to get that du value, in order to add it into the function, we need to take its reciprocal and multiply it by the integration. And that's because the coefficient of du is 2. And there's nowhere that we can get that in unless we multiply the reciprocal of 2 to cancel off the coefficient. So our function is going to be 1/2 the reciprocal of 2 times the integration of du, which we're plugging in for that x value, because we were able to take this reciprocal, or use that reciprocal. And then so it's du times 3, and now this value up here, this x squared plus 1, since it equals our u value, we can substitute in the u. So it's very convenient like that. So it's 3 to the u. And we usually write that with the du over here. So it would be 1/2 times the integration of 3 to the u du. There we go. Okay. So here's the next step. So we need, since finding the derivative of a coefficient to a power is always the natural log of that coefficient times the coefficient to the power, we're going to need to get a little bit tricky at this point. So this coefficient, or this reciprocal on the outside, we're going to need to multiply that by the natural log of 3. And we're going to need to do that because the derivative of 3 to the u would be the natural log of 3 times 3 to the u. And so we need to get that into the function, and in order to do that, we need to multiply by natural log of 3, because we're going to put the natural log of 3 times 3 to the u into the actual integration. So we're going to come out with 1 over 2 times the natural log of 3. And that's just 1/2 times natural log of 3. Times the integration of the natural log of 3 times 3 to the u du. And so we're doing this because the integration of 3u has to equal the derivative of 3u. And that's what this is. So now we're going to integrate, and we're going to come out with, we're going to get rid of this integrations, this sign, right? Oh, my pen stopped working. This sign right here. And it's going to come out as 1 over 2 times the natural log of 3 times 3 to the u plus c. Remember that c because we're integrating. So now we're very close to our answer, and all we have to do is look at this u, and we have to get rid of it. We put it in, now we're getting rid of it. And this is where we come up with our final answer. Because it's an indefinite integral, in indefinite integration, we're not going to come out with a value, we're going to come out with an equation. And so in order to come out with that equation with an x value, we need to replace that u with the x value that we originally replaced it with. So we're going to come out with, as our final answer, 1 over 2 times the natural log of 3. It's a little messy, it's okay. Times 3 to the x squared plus 1 plus c. And that is our final answer.
So the next problem is problem number 12, which is the integration from 0 to radical pi of x sine of x squared dx. Now the first step of solving this definite integral is find u, du, dx, and du. So first of all, u equals x squared because it's the inside function. Come on, there we go. That's x squared. Hope you can read it. Du dx is the derivative of that, which is 2x. And then you need to solve for du, so multiply dx across. So du equals 2x times dx. Now that you have that, you can substitute the u and the du back into the original function. So from the integral of 0 to radical pi, you have 2x times sine of u dx. But now that you put a 2 right here inside the function, you need to multiply the reciprocal to cancel that out. So that's going to be 1/2 on the outside. Now that you have that, you can simplify, and the 2x for the du over here can now be substituted for du. So the 1/2 carries down from 0 to radical pi of sine of u, sine of u times du. Now that we have that, we can integrate that and find the antiderivative of this inside part, which is negative cosine of x squared. If you just replace the u with the x squared in the first place, back in from 0 to radical pi. Now what we need to do next is to subtract the minimum from the maximum in order to get the area in between the point A and point B of this graph. And to do that, you need to, there's 1/2 out there, you need to do this. You need to do 1/2 times negative cosine, oh, that was not good, times negative cosine of, so radical pi squared just becomes pi minus 1/2 times cosine of 0. And then if you do this out, it ends up being 0.5 minus negative 0.5. And your answer becomes 1. And that's the answer of the area underneath the graph from point A to point B being 0 to radical pi.